Hello, second graders. Mrs. Hagedorn here. We are going to be working again today on the math playground. So I'm going to, on my iPad, come over here where I have the math playground app saved and it says Thinking Blocks. I'm going to go ahead and open that. And right now it looks like I'm in Thinking Blocks Junior. So I'm going to go up to the second grade tab and touch that. And when I get into the second grade tab, I'm going to scroll down to the second grade games, and I'm going to go into Thinking Blocks today. So once I'm into Thinking Blocks Edition, I'm going to continue to scroll down, and we are going to be playing Thinking Blocks Edition.
Let's get started.
And in this one today, we are now going to be playing in the second row, the last game. We're going to be working with random models. So random models is going to be a collection and an assortment of different types of story problems that will help us practice all the story problems we have practiced so far this year. So let's go ahead and listen to our first word problem.
Nathan read 21 pages yesterday and 11 pages today. If he reads 17 more pages, he will finish his book. How many pages are in Nathan's book?
Okay, so if we take and we think about Nathan read 21 pages yesterday, 11 pages today. If he reads 17 more pages, he will finish his book. How many pages are in his book? So in this one,
Total pages.
believe my total pages is the total amount I have.
Pages yesterday. Pages today. Pages left.
And that's the way that it kind of talks about it. I really don't know if the colored bars matter. All right, but now that we have the bars in place and we know how many pages we have, we can go ahead and we can start to think about what we know. Nathan read 21 pages yesterday. So I'm going to put that down by pages read yesterday. He read 11 pages today. If he reads 17 more pages, he will finish his book. How many pages has he read in all? I am not sure, so I'm going to go ahead and check that. All right, and then again, we can notice that our bars kind of come out proportionally. So we are adding 21 plus 11 plus 17. So 7 ones, 1 1, and 1 1, I believe is going to be 9 ones. 2 10s, 1 10, and 1 10 is going to make 4 10s. So I think our number is going to be 49. And now we're going to go on to the next problem. Hagedorn is going to go ahead and listen to it. Maybe not. Our classroom library has 24 puzzle books. There are 15 fewer reference books than puzzle books. There are 4 fewer history books than reference books. What is the total number of books in the library? All right. I always feel more comfortable if I read it the second time. Our classroom library has 24 puzzle books. There are 15 fewer reference books than puzzle books. That must mean I have less reference books than puzzle books. There are 4 fewer history books than reference books. So I'm thinking right now the most I have of something is puzzle books. Then I have that there are 15 fewer reference books than puzzle books, and there are 4 fewer history books than reference books. So I believe puzzle books has the most, reference books has the next amount, and then history books has the least. Now I have to look and compare my numbers and see if I can match these up too. Our classroom library has 24 puzzle books. So I can find 24. There are 15 fewer reference books than puzzle books. I don't know how many reference books there are, but I know that there are 15 fewer. There are 4 fewer history books than reference books. So again, I don't know how many history books there are, but I know that there's 4 fewer, which means I don't know how many reference books, like I said, I don't know how many history books are, and I definitely don't know how many books there are altogether. So now I kind of have to work backwards here, my friends. And I have to think that I know, in this case, that with my larger bar of puzzle books, there's 15 less. So something plus 15 is going to be 24. And I believe that if I have 9 and 15, that is 24. Then I can look down below here to history books and know that there are 4 fewer, so something plus 4 is going to equal 9, so I believe that's going to be 5. And then what it wants me to do is it wants me to find out how many books there are altogether, which I can get from adding up the 24 puzzle books, the 9 reference books, and the 5 history books. Oh, let me see here. 9 and 5 is going to be 14, and then 24. I think my total number of books is 38. So down here in my question to my actual answer, what is the total number of library books? And I believe that is 38. So now I would go on to the next type of question. Some children went to the math workshop. There are 28 girls and 16 boys. How many children went to the workshop? Well, I know that some children went to the workshop. I don't know how many. I believe that is my total number. I know that there are some girls and there are some boys. There are 28 girls and there are 16 boys. So now I can go ahead and put my numbers in where my bars are. And I already said there were 28 girls and there were 16 boys. And I'm still trying to find out how many total children went to the workshop. And now I can see that I'm going to have to add those two numbers together to get my total. Remember, Mrs. Hagedorn has kind of told you before, this is kind of like a math mountain, if you want to think about it. So 28 and 16, I believe that number is 54. It is not, Mrs. Hagedorn. Well, think about it again, Mrs. Hagedorn. 8 and 6 is 14. 2 10s and 1 10, and then another 10 is 44. There we go. Okay. Riley has a piece of rope that is 47 inches long. It is 24 inches longer than Nicole's rope. What is the length of Nicole's rope? I know that Riley's is 47, and it is 24 inches longer than Nicole's rope. That must mean that Riley's rope is longer than Nicole's rope. So here we have what looks like it's going to be a comparison bar. And now we know again that Riley's rope is 47 inches, and we know that that is 24 inches longer than Nicole's rope. What is Nicole's rope? I don't know what Nicole's rope is, but I do know that it is 24 inches, takes another 24 inches with Nicole's rope to make Riley's rope. So we're going to check this. And now we use our comparison bar and we think again. We think that 24 plus Nicole's rope is going to equal 47. So I think this one is 23. All right, on to my next question. Okay, 22 children waited in line for the birthday party. 16 more children joined them. Some children left to buy snacks. There are 26 children in line then. How many children left to buy snacks? This one has a hidden question. How many children in all? There is more than one step to this question, so I'm going to read it again. 22 children waited in line for the birthday party. 16 more children joined them. Some children left to buy snacks. There are 26 children in line then how many children left to buy snacks? So I think this is my total number of children. I think over here is my children in line and my children that joined the line. I'm going to bring my bars up to check my thinking here. All right. Do I know the total number of children? I do not. I know there were 22 children that waited in line for the birthday party. So 22 waited in line. 16 more joined. I do not know the total number that were in line. So now, again, think again of like this is kind of like your math mountain. So 22 and 16 is going to make my total number of children. So to ask that first question, how many children in all, I believe that I'm going to have 38. So that's the first step. Now let's go on to step 2. So now I know that the total number of children is 38. That's down here, 38 children. Then I have my children that were left and my children that stayed. All right, let's check this out. When I look back up above, it says some children left to buy snacks. That means I don't know how many children left. There are 26 children in line then, so there was 26 children in line then. How many left to buy snacks? So again, I have to think of, when I think of this, if 38 is my total number, 26 and what make 38? And I believe that answer is going to be 12. Okay, friends, looks like I've completed this game. And as you can see, I've done random models. I can replay it. Yes or no, I'm going to hit yes. And I'm going to go ahead and start the game again. I hope that you enjoy doing a bunch of different types of word problems. Some are part whole 2-part. Some were part whole 3-part. Some were compare 1-step or compare 2-step or even compare 3-step. So all of these we have worked on. Change 2-step, work backward, compare 3-step. I know that word problems aren't easy, but the more time that you take really trying to figure out what the question's asking you to do, the easier it's going to be. Thanks for another great day of math, mathematicians. See you later.